Good afternoon, everybody. So I wanted to share some observations that I've been making along with Jenna about Faustini Rim A, which is one of the 13 Artemis candidate landing regions. I pressed the right arrow. So this is an area that is located between Amundsen and Shoemaker, and it's located right on the rim of Faustini crater. And the most recent stratigraphy places these craters between about 3.9 and 4.2 billion years in age, although some samples would be really great to actually verify this stratigraphy. There's also many other possible crater sources and ejecta located in this region, and these events likely spanned a large range of lunar history from the pre-Nectarian to present day, essentially, when we have ongoing impacts happening. From what we know about the mineralogy of the area, from the data we have, we know it's largely feldspathic. And in terms of what else we might find at the surface, we have several nearby basins, particularly Schrodinger and that awkwardly named unnamed basin that was the previous speaker was just talking about. And there's also the South Pole Aitken Basin, which has likely contributed some of the materials to the surface here as well. So the regolith here is going to have components of all these different impact events, as well as many of the basins in the region. And so we're going to get a lot of information if we go here about global history, as well as more regional and local impact history. This is a prominent crater that's in the area besides Faustini, and I think Jenna talked about it a little bit in her talk a couple before mine. It's about 2.7 kilometers in diameter. It's unnamed. It's relatively fresh. You can see it in this DAC image here. The mini-RF radar data also indicate that its ejecta is relatively young and it's very rough. This crater can excavate depths of up to about 270 meters below the surface. So it can give us some insight into what's below the surface as well by looking at its ejecta. So the other thing to look for here would be rocks and blocks or boulders that we can sample and hopefully collect information from. And so there are quite a few blocks and boulders exposed in this area, particularly associated with that young impact crater. There's some examples of younger, smaller craters like the one in the center. And this is about a 50-meter diameter crater, and it's exposing a number of rocks and boulders. And there's also areas like the one on the left here, which are more like a clustering of boulders. And this is an area that's about 100 meters across. And then there are also isolated ones like the one on the far right. These are isolated strewn ejecta boulders that are about 10 meters in diameter each. So I went through and mapped out all of the boulders that I could find in this area using the images from the NAC, the LROC NAC camera. And they're shown here in the yellow dots on the far right. And you can see a lot of them are associated with that younger crater and its ejecta, but also a lot of them are found inside Faustini. That's the region that's, it's been colored brown, which you may or may not be able to see, but the young ejecta is the green area, and where the label is the Faustini's interior. Down here on the left, there's also an example of the high resolution NAC images showing a lot of these large boulders. They're strewn throughout this area, and these little blue arrows here highlight a few of them, just in case you can't really see them. So of course we'd want to actually be able to access a lot of those materials. And so looking at the slopes, this is a slope map showing relatively mild slopes in blue, those less than 10 degrees, using the highest available Lola topography. Other colors indicate steeper slopes. So you can see the steeper slopes are inside Faustini crater, and a lot of the young ejecta and its surroundings, as well as a lot of those yellow dots, which mark boulders, are within the bluer areas, and so they are technically accessible. Also, it'd be nice if we could sample volatiles and do a lot of our science about volatiles and volatile processes. So shown here now, I have in dark red the large PSR regions Those are bounded by very steep slopes, and so they're probably not really accessible. But a lot of the more orange to reddish colors indicate more medium to smaller scale PSRs. And you can see that a lot of those are in close proximity to this blue terrain or the blue colored terrain. So those are accessible. A lot of them are also associated with small craters, and others are probably older degraded craters. But you can see that there are a lot of them in this area, and they're scattered around the region. The other thing to know about this area is that I think Jenna might have mentioned it, but that young crater in Sajecta has an associated mineralogy mapper water ice detection as well, which makes it pretty interesting. So in terms of accessibility, also we have to think about the illumination. So to do a preliminary evaluation of that, which other people can follow up on in more detail, using the quick map simulated illumination, I went through a series of time steps and also divided the area into 3 basic areas just for convenience and ease of talking about them really. The Faustini interior, the crater, and a ridge area, which is along Faustini's rim, and it's actually the highest point of elevation as well in this area. So looking through time steps of these areas, I found that generally the ridge and that crater are not frequently co-illuminated. They're often, one will be in darkness and then the other will be in sunlight. The example here is a rare case where I actually found that they were co-illuminated at the same time. But in general, though, there are areas of portions of this image which are illuminated for at least 6 consecutive days, especially around that crater, which I think is of particular interest. And so I think, with some further analysis here is merited, considering that this is possible. And then looking at different times, I think when this is accessible will depend largely on launch. So you might want to think about tying the actual planned mission dates into this analysis as well. I found that if you look at February of 2023 versus February of 2026, you have a change in seasons on the moon. And so you actually get worsening illumination conditions at this site. So somebody needs to go through and search for ideal missions. But again, I think it's merited. Oh, and here's a quick little video just stepping through those time steps to give you an idea of what I was talking about, how different portions of this region are illuminated at different times. So in summary, I think this site is really interesting because it has access to volatiles. It also has an access to many impact materials. It has relatively cool temperatures and relatively low illumination, which is pretty good for volatiles in terms of objectives that we can study. It does potentially add a little bit of difficulty for mission planning. But again, I think it's merited to continue to consider this site. And there's that little ridge that I briefly mentioned up on the rim of Faustini crater, and it has the best illumination as well as the best Earth visibility in this region, but it does max out at about 50% of the time, and that is based on these Lola average data sets. So, and then my final point here is about the suitability for a base camp. And I think that would depend. I think there's a lot of things to study here, which makes it very interesting. But in terms of feasibility, it depends on the technical capabilities, as well as what architecture might be adopted. But I could conceive of maybe something where you would go to that ridge in an earlier mission, and then you could expand to some of these other areas for follow-up study. But there are some pretty good size distances to consider, just note that between the ridge and that crater is more than 10 kilometers. So anyway, I just want to thank all the people who made the data that went into this study, and that's all I have.